Okay, this chapter is going to be about acids, bases, and neutralization. There's a little bit in chapter 20, a little bit in chapter 21, so we kind of take the most important information from both parts and put it in one chapter. Okay, so first things first, what is an acid and what is a base? All right, historically, before they knew about our atoms and our molecules and elements, they knew that there were different substances that had different kinds of properties. All right, and they characterized acids as things that are sour, like lemons and candy and all of our citrus fruits. This does not mean, and I will say it again, do not taste chemicals. All right, you can't go up to any chemical and be like, "Oh, I'm going to eat it." No, 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 no. Another property that they started to observe is that they would corrode some metals. You couldn't store vinegar and other juices in metal containers. And there's litmus, which is a special type of molecule that gets put on some filter paper and it would make it change to the color red. Okay, bases, on the other hand, also referred to as an alkaline substance, so you might see that in some things like batteries. Bases were bitter, they were slippery, so that's going to be all of your soaps. What it does is it actually ends up eating away some of the acids of your on your skin, and that's what makes it feel very slippery. And it would turn litmus blue. So you can remember the bases by the B's. All right, so bases are bitter and they turn litmus blue, BBB. All right, and acids are going to be the opposite. You're going to find that a lot of stuff in these chapters is like this scale that's the background. You know, it's either one way or it is the other. So obviously we have more commonly known citrus fruits for our acidic food, with your tangerines and your oranges and your limes and your grapefruits and our Sour Patch Kids and sour rods and all that kind of stuff. Vinegar is an acid and milk is an acid. Ketchup has vinegar in it. Soft drinks with a carbonic acid, they are all acidic substances. And then your alkaline food is going to be more of your dark green stuff. And that's going to be your celery, your broccoli, your cucumbers and lettuce, wheatgrass, kale. And if you think about them, like especially spinach and collard greens and chard and mustard and all that, they are really kind of bitter. And that is because they are basic in nature. All right, so what does it mean in the chemical aspect for being an acid and base? Well, there was a scientist by the name of Arrhenius who first figured out that all of these acids are able to produce a hydrogen ion. And here we are talking about ions again. Okay, so H plus, the hydrogen ion, means that they are able to donate that. So HCl, probably the most famous of all the acids, is going to be H plus and Cl minus. Okay, so it breaks up, kind of the opposite of what we did with ionic bonding. So you see that dissociation in there. For bases, he said that they were going to be substances that contain hydroxide. So sodium hydroxide, which is lye, and what we use in order to make soap, is going to donate these OHs. And then Arrhenius did something very brilliant, which is probably common knowledge at this point. He figured out that your acids with the H plus and your bases with the OH minus neutralize one another. So what do you get with H and OH? You get H2O. And that in 1903 awarded him the Nobel Prize in Chemistry, insisting that acids and bases cancel each other out. If you've seen the movie Fight Club, you know that he gives him a base burn. And at base burn, he says he puts NaOH on it. And he's like, you can either add water to it and it makes the burn worse. Okay, so water isn't always the key. Or you could take some vinegar and neutralize it. And the vinegar neutralizes it to make water, and so that the stirring won't hurt anymore. All right. So one of the fundamental issues with our acids being H plus is that this H plus ion is really, really small. Remember, hydrogen is number 1 on the periodic table. It has 1 proton and it has 1 electron. So if we make it an H plus, we're getting rid of that electron. It's really just a little itty bitty thing. It's unlikely to exist by itself. And since there will be water around, the water gobbles it up and it makes the hydronium ion. So this is ion number 77 that you need to know. The hydronium ion, H3O+. That is what is actually in all of your acidic substances. It looks just like water with its oxygen right here. And then you have your hydrogen and your hydrogen here. But it gobbled up another hydrogen from the acidic nature, and it makes this structure right here. So it looks like our little tripod, and it has a positive charge. All right, but there is an issue with the 1903 way of thinking of acids and bases. It assumes that all bases are going to have hydroxide ions, but other things have the same type of basic properties and are able to neutralize acids. So we have to change those, and you'll see in upcoming videos we talk about Bronsted-Lowry, and we talk about Lewis acids and Lewis bases. Okay, so we're going to mainly identify with the Bronsted-Lowry acid-base definition, and then we'll talk about Lewis. But like ammonia, the common cleaner that you guys have in your house, or a carbonate like your chalk and your metal oxides and fluorides, those are all considered bases, but they don't contain the hydroxide ions. All right, so quick little thing. Got to review the naming of acids because that's what we're talking about this chapter. We have 2 major kinds of acids. Okay, we have our binary acids, which is just H and an element. And when we name that, we use hydro, whatever the element is, ic acid. So HCl is hydrochloric acid. H2S is hydrosulfuric acid. And you'll remember that S is a 2- because he's in column 16. So if you have H plus and S2-, when I crisscross, it's H2S in order to get my neutral ion. For hydrochloric acid, it's H plus, and Cl minus, crisscross, it's HCl. All right, so those are your binary acids. You would also have like hydrofluoric acid, hydrobromic acid, hydroiodic acid, okay, but they use that terminology hydro in front. The other acid is the one that students tend to have more difficulty with because you got to know your ions. Those are our oxyacids. That is hydrogen and a polyatomic ion. And this is where we talk about our dessert. Remember how to remember to name our stuff with desserts? Think of your favorite dessert. I took a bite. It was delicious. I ate the whole dessert. I got sick. All right, so the ite ending polyatomic ions end in us. The ate polyatomic ions end in ic. All right, so HNO3, NO3 is nitrate. So I ate the whole thing, that becomes nitric acid. Oops, nitric acid. All right, NO2, on the other hand, is nitrite. So you got to recognize those. All right, so the nitrite, all right, becomes nitrous acid. I took a bite, it was delicious. C2H3O2 is acetic, that comes from acetate. PO3 comes from phosphite. All right, so make sure that you know that this becomes an ic and this becomes an us. Remember your ions. The ions will always be there for you.